MA161, Chapter 1.6, Variation and Application. In this section, we will learn direct variation and indirect variation, inverse variation, joint variation, and so on. So typically, there are two types of variation, direct and inverse variation. So first of all, direct variation is this. Okay, if a sentence starts with, y varies directly as x. So there is a word directly. Then we can write the expression. Okay, this is really simple expression. So write down y. So y equals, this is an equation, directly as x. Then there is a constant of variation, some number k, and then this k is multiplied by x. The variable that comes after as. Very simple. So also, if there's a sentence like this, y is directly proportional to x, then the equation is the same. So the equation for this sentence will be this one. So y is the subject, and x is the variable comes from after s and t, or 2. And directly means multiply directly. So we call this k is a number, we call this constant of variation. Constant of variation. Okay, so in order to write an equation, we need to find the value of k, the actual k value. So this k value will be found when we substitute the values of x and y for x and y. So always the value of x and y will be given for us to find the constant of variation value. Always given. So let's see the next example. Example 1. The distance that sound travels varies directly. Here's a directly, right? So this is direct variation. As the time the sound travels. So we can write an equation. Let's say the distance. Let's make a variable d, the distance, and then time. Let's use t to represent the time the sound travels. So the distance, this is direct variation. So d equals, we write k and then followed by time. Then we need to find the value of k, the constant of variation. So in that case, always the value of time and the distance will be given. So as you see this, if sound travels 1,340 meters, so this is the what? Distance, right? In 4 seconds. So this is the time in seconds. Then find the distance sound will travel in 5 seconds. So first of all, we need to find k. So let's plug in the distance and the time. So the distance is 1,340 equals k times, the time is 4 seconds. So from here, let's find k and divide each side by k, so 4. Then it will be 1,340 divided by 4. Then k equals 335. So we found the value of k, the constant of variation. So rewrite the equation. So we are ready. So we are ready to answer. When the t value is given, then we can find the distance, and distance value is given, then we can find the time. So now let's look at the question. So we want to find the distance that the sound will travel in 5 seconds. So this 5 seconds is the time, right? The time for us to find the distance when the time is 5 seconds. So the distance is equal to 335 multiplied by 5. So finally, if after 5 seconds, then the sound travels this much. So that is 1,675 meters. Okay. So direct variation is really simple. What you have to do is write an equation, y equals k times something. multiply. Okay, multiply. So directly means multiply. Multiply. All right, then next example. Okay, the distance s that an object falls from a rest varies directly. So the distance varies directly as the square of the time. Okay, what do you mean by the square of the time? Square of the time means, what's the expression for this? That is square of t, right? Here's a t, square of t. So t squared. Let's say time is t, right? Okay, already given. Time is t, sorry. So time is t. So the distance s will vary directly as t squared. So we can write an equation. The distance s equals k times k, and the directly means multiply, right? Multiply k, right? Multiply k. So k times what? Square of the time, so t squared. All right, so this is the equation. We need to find the value of k. So let's see. Is the distance s and time given? Yes, of course. If an object falls 64 feet, so 64 feet is the distance, and 2 seconds will be the time, right? So plug in these numbers. So 64 equals k times 2 squared. Then we want to find the k. So divide each side by 4. So k equals 16, right? 16. All right, so once we found the k, rewrite the equation. So rewrite the equation. S equals 16t squared. So this is a general equation. And then the last sentence is, how far will it fall in 10 seconds? So 10 seconds. So just plug in 10. So 10 seconds, right? The time is t. So plug in 10. Then S equals 16 times 10 squared. S equals 16 times 100. So the distance will be 1600. So 1600 feet in t seconds, in the 10 seconds. All right, nothing special. What we have to do is write an equation. Okay, now inverse variation. Inverse variation is also really simple. Okay, y varies. The inverse variation is this. Always there's a inversely, the word inversely. So y varies inversely as x. That means y equals, so write down k. The inversely, once you have inversely, then we divide it. Divide k. Okay, divide k by x. So in that case, we will divide this k by what? What comes, the variable that comes later. So inversely as x. So x will be the denominator like this. Okay, so this is the expression of the inverse variation. So y is inversely proportional to x. Same thing. The equations are the same. So k divided by x. Simple, isn't it? So direct variation means multiply k. Inverse variation is what? Divide k. So for this example, the volume V varies inversely. Inversely. So what we do is divide, right? Divide k by what comes later. So inversely as the pressure. So this is an inverse variation. So we can write the volume equals k divided by the pressure. Simple, right? And then V and P value will be given. So the volume is 75 milliliters. So that is the volume V, right? This is the volume V. So when the pressure is 1.5 atmosphere, so this is the pressure. So using these two values, we can find the constant of variation, K. So the volume is 75 equals K divided by 1.5. So multiply each side by 5. 1.5. So that's the K value. So So K equals 75 times 1.5 is 112.5. So rewrite the equation. So the volume will be 112.5 over P. So if P is given, then we can find the volume. If the volume is given, we can find the pressure. So in this question, the pressure is given. The pressure value is given, so we can find the volume. Then the volume will be 100. So here, the pressure, let me write the pressure first. In this case, the pressure is what? 2.5. So we'll plug in 2.5. So the volume will be 112.5 over 2.5. Then use your calculator, then this will be 45. So the volume will be 45 milliliters, ml, right, milliliters. So this chapter is pretty easy, an easy-going chapter. Okay, next example. Okay, similarly to the inverse variation and direct variation, we're gonna do, we'll just follow the properties. So the sound intensity, so the intensity, let's use I. Intensity, let's use I. So this I is inversely proportional. So here's inversely. So we can write, this is inverse variation. So write down the intensity equals, inversely means divide K, right? Divide K to the, divided by the variable that comes later. So it's proportional to what? The square of the distance. So if the distance is D, then the expression for the square of the distance is D squared, right? D squared. So we can write it as D squared in the denominator. And I and D values will be given. So the intensity is this much. So this will be the intensity value at a distance of 4 meters. So 4 meters will be the value of the distance. So just plug it in. So 2 times 10 to the negative third power equals K over 4 squared. Then multiply each side by 4 squared, which is 16, right? 16. So K equals 16 times 2 times 10 to the negative third power. Then K equals, alright, so this is 32, right? 32 times 10 to the negative third. So K equals, move the decimal point 3 places to the left. So 0.032. So that's the, so we found K, then rewrite the equation. So the intensity is 0.032 over D squared. And what's the intensity when the distance is 2 meters? So the distance value is given. So replace this distance D with 2. So the intensity is 0.032 divided by 2 squared, which is 4. Then divide this number by 4. Then the intensity will be 0.008. So the unit is watts per square meters. Okay. So nothing special, all same. Even joint variation, still same. The joint variation means this is a direct variation. What we have to do is just multiply, keep multiplying the variables. So y varies jointly. Okay, this is same as what? Direct variation. So y equals k times, and this one has more than one variable. That's why we are using jointly. So there are 2 variables, x and y. Then it will be x times y. Simple, isn't it? Okay, so let's do the example. The cost, let's say the cost is C, varies jointly. This means there will be more than one variable. Okay, as the thickness, let's say T, and the area, A. Alright, so we can write an equation. The cost will be is equal to K times what? T and the thickness and the area. And it costs $1,750. So all the values of C, T, and area will be given. So this will be the value for the cost, and the area is given. So this is the area value. And then the thickness 4 meters. So this is the thickness. All right, so replace these variables with the given numbers. So 1,750 equals K times the thickness is 2,100 multiplied by the thickness, which is 4. So K equals, we can divide each side by 2,104, right? All right, so what is the K value? Use the calculator. Then the K value will be like, okay, there's 5 over 24. So replace this one, replace this to the equation. So C equals 5 over 24 times TA, okay, TA. All right, then let's find the cost. Let's find the cost when the area. So the area is given and the thickness is given. So plug in these numbers. So C equals 5 over 24 times the thickness is 6 and the area is 2,400. So when we simplify this one, it will be 3,000. So the cost is $3,000. Okay, the next example shows it combines direct variation and inverse variation. So let's check how it happens. The weight varies. So the weight, let's use W, varies jointly. Okay, jointly means there are more variables coming, and the width and the square of the depth. So D squared, okay, square of the depth. And then what? It says inversely, right? Inversely means divide, right? Divide as the length, L. So jointly means multiply, right? Multiply. And the inversely means divide. So using this information, let's find the K value. So the weight equals the constant variation times, jointly, varies jointly as width and the square of the depth, so D squared. And then inversely, varies inversely, so we divide everything by what? The length. All right, then from this we can find the K value. All right, the next sentence gives us the values of the variables. The weight. Okay, let's use a different notation. We have two W's, right? So let's use the weight is the load, L. Let's use L. Okay, so let's use L. All right, so, okay, 4 by 4, 4 foot long. So 4 foot long this is the length, isn't it? This is the length. Okay, the capital L is the load, the weight, and the lowercase l is the length. Don't get confused. And then 4 by 4 inch beam. Then that is the width, isn't it? 4 by 4. Okay, so that is one moment. Okay, so 4 by 4 means this is the this shows this 4 is the width and this 4 is the depth. Can you see it? So if we have a beam, you have a beam like this, right? You have a beam like this. Then this is the width. This is the depth. So 4 by 4 means this is 4 and this is 4. All right, then it supports a load of 256 pounds. So this is the load, large capital letter L. All right, so let's use these values. So the load is 256. So that equals K times the width is 4 and the depth is 4. So 4 squared over the length is also 4. 4 foot. Okay, we are using inches, right? Inches. So 4 foot is how many inches is it? Okay, in that case, we don't have to convert this foot into inches because when we were asked, the length will be given as feet, right? Feet. So we'll just leave it like this. So in this case, we can find the K. So we can reduce this 4. So if we rewrite it, then K equals what? So reduce 4 from each side, from each numerator and denominator. So K will be 256 divided by 4 squared. 4 squared, which is 16. So K equals divided by 16. So that would be K equals 40. Oh, okay, K will be 40. Okay, I'm sorry. I copied the wrong information. So this is a not 4 foot long. This is a 10 feet long. 10 foot long. So this will be a 10 foot long. So this length will be 10, right? Okay. So the length will be 10. That is not 4. Sorry about this. So K will be 256 times 10 divided by 4 and 4 squared. So once we simplify this, then K will be 40. All right, so rewrite the equation. The equation for the load will be 40 times W times D squared over the length. All right, then from this, okay, let's plug in all these values. Okay, the width is 4. The width is 4. The depth is 6. And the length is 16. All right, so the load equals 40 times width is 4. The depth is 6 inches, so 6 squared over the length is 16. All right, then the L value will be, the load will be 360. This is the pounds. All right. So setting an equation is really important. So for the direct variation, inverse variation, and jointly is similar to this combining both, right? So write an equation based on the direct and inverse variation. And then find the constant of variation, the K value. In order to find the K value, other variables value will be given. So once you find the K, rewrite the equation, then find what the question is asking. All right, so that's it for this section. This section is really simple and short.